Welcome back. The sun's a pretty dynamic place. There's a lot of activity happening there every day, and if it wasn't for how darned hot it was, we would have gone there by now to learn some of its secrets. But with the help of some new spacecraft, that could all change. We might finally be going there to check it out. There's an international effort to build the Solar Orbiter, or SOLO, that will get us up close and personal with the sun to fill us in all the hottest details. Talking to me now is Chris Owen, principal investigator of the SOLO mission. Thanks for joining me, Chris.
You're welcome.
So, sending a spacecraft to the sun, what exactly is the Solar Orbiter going to do? Okay,
so the real new stuff that we're doing here is we're going to take the spacecraft and we're going to get rather closer than we've ever gone before. We're also going to try to get it to go up above the poles of the sun as well, so we get a view of the sun from above. But also the instrument payload is rather unique for this mission as well.
Now, sorry, you say the poles of the sun. Does the sun spin around like the Earth does?
Oh, that's right. The sun spins on its axis once about every 27 days.
Huh. I did not know that. So how close are you going to get with the Solar Orbiter?
So this mission gets just inside of the orbit of Mercury, which is roughly just less than a third the distance from the Earth to the sun.
And what is it exactly that you can learn when you're that close that we can't already learn from, as far away as Earth is?
So at the Earth, we see what's known as the solar wind, which is a stream of charged gas that comes out from the sun. By the time it's got to the Earth, it's been through kind of a lot of turbulence and sort of internal interactions. What we want to do with this mission is to get in close enough so that what's happened to the solar wind during its journey is not as important as how it was actually formed. What we're looking for is the fingerprints of the formation of the solar wind on the surface of the sun.
So imagine when you're close to the sun that heat is a major problem. Are there any other challenges associated with putting the Solar Orbiter that close to the sun?
The front side of the spacecraft is exposed to very high temperatures, probably several hundred degrees, maybe up to 500 degrees centigrade. So the instruments that need to look out through the heat shield towards the front of the spacecraft have to deal with very high temperatures. But conversely, there are some of the instruments, particularly those in the in situ group, that are located on parts of the spacecraft that will always be in shadow. And because they never see the sun, they're exposed to the cold of space. So if those instruments are left to their own devices, they will actually go down to temperatures of minus 100 plus degrees. So that the part of the trick there is that we might actually have to run heaters to keep those instruments alive. So it's a bit bizarre, very hot on the front side of the spacecraft, but extremely cold on the back side.
Well, this heat shield, how does that work? Is it just insulation? Because wouldn't that just heat up after a longer period of time?
It's made up of many different layers, kind of that are stood off on little stilts. So what happens is that each layer, the temperature that is radiated from one layer to the other, it goes down as you go through. So although the front side might be many hundreds of degrees centigrade, by the time you get to the spacecraft, the temperature is reduced and the extra energy is kind of radiated out of the sides of the heat shield.
Okay. So what components are going to be on there collecting data?
There are 10 instruments in total on the mission. They can be kind of divided into two groups. One of them is what we call remote sensing instruments, and by and large they consist of different telescopes that will image the sun at different wavelengths. There's another group that we call the in situ instruments, and they're the ones that actually are on the spacecraft, and they're sort of sniffing the solar wind as it comes out past the spacecraft. So the idea is that we kind of be able to make up a link between what's happening on the sun as observed by the remote sensing group with what actually comes out past the spacecraft shortly afterwards that is then detected by the in situ group.
So how soon is this going to go up and start orbiting the sun? And then once it's there, how long will it stay there?
Okay, so the mission was approved fairly recently, at the end of last year. The launch date is currently in January 2017. There is a cruise phase to get it down into its operational orbit, and then the mission will be the nominal mission is for 3 years, although we would hope that like many other missions that we've been involved in the past, that it'll get an extension, and we could go for maybe 9-10 years if we're lucky.
Well, it's exciting stuff, and we thank you so much for telling us about it.
You're welcome.